Good afternoon, and welcome to this afternoon's Plant Engineering webcast. Keep your cool while keeping your facilities cool. Thanks for joining us today. I'm your moderator, Bob Vavra, Content Manager for Plant Engineering Magazine. I'm now happy to introduce today's speaker. Jim Magallanes is the president of Technicool Innovations, Inc. He has more than 20 years of experience with portable cooling. Throughout his career, he's engineered 12 air conditioners specifically for spot cooling people, equipment, and production processes. A number of portable air conditioners that Jim has helped engineer have gone on to become best-selling models year after year for more than a decade. He's a recognized industry expert in people and process cooling over a diverse range of industries, and he's incorporated spot cooling to help numerous manufacturing companies increase worker productivity, reduce production process times, and comply with worker safety laws. Jim's comprehensive knowledge in designing spot cooling air conditioning and his long career of utilizing them within an industrial setting makes him uniquely qualified to solve the most difficult heat challenges at an affordable price. Jim holds a Bachelor of Science in Mechanical Engineering from the University of Pennsylvania, go Quakers, as well as a Master's of Business Administration from the University of Southern California, of course, go Trojans. Jim, good afternoon. Welcome to our webcast, and thanks for joining us today.
Thank you, Bob, and welcome to everyone joining us today on Cooling Down Your Plant. In today's presentation, I'll talk about industrial cooling and the unique variables that come to that, the challenges that go along with cooling such a large space, and the heat trapped inside that warehouse. From there, I'll talk about portable air conditioners, the insulation of these units, talk about people cooling, process cooling, equipment cooling, all the different types of cooling that you find in these type of large warehouses, production floors. From there, we'll talk about AC rental companies, companies throughout the U.S. to help you out with emergency cooling, and then we'll transition into having an emergency preparedness plan, being prepared for anything that nature throws at you. And after that, we'll talk about all the different cooling solutions, whether it's fan, evaporative, and revisit portable AC, ducted spot AC cooling solutions, and talk about each one of those and what might best work for your location. And after that, if you decided to select a portable air conditioner that works for your warehouse or production floor, we'll talk about what to look for in selecting a portable air conditioner and lowering that total cost of ownership. And with that, we'll wrap it up and start taking questions. So the industrial sector, it's a very difficult to cool down a large warehouse, a large open working space. A lot of times you have people moving around in such a large area that cooling down the entire space isn't really practical. You also have large shipping doors that may be open throughout the day, letting in warm, hot air, moist air, also dust and contaminants as well. And then having heat-producing equipment trapped inside those warehouses will also elevate those temperatures, and then any type of processes that are in there that raises the temperatures as well. So a lot of times those indoor temperatures greatly exceed the outdoor temperatures outside the warehouse. So you factor all that in, plus the harsh conditions of, whether it's dirt, debris, or oil, or chemicals that come along with your industry. It's just a real challenge to keep that space cool. So if you look at traditional AC cooling down the whole space, the capital costs associated with that, whether it's the initial capital cost of the equipment itself or the ongoing operating expense of that equipment, is just kind of astronomical. And it doesn't work out in every industry. Some industries, like pharmaceuticals, they require the whole production floor be cooled or climate controlled. But we'll focus more on industries that can get away from that a little bit and make your workers more comfortable, as well as your products and processes more reliable and deliver a quality product to your customers. So with that, we'll transition into spot cooling using portable air conditioners. So spot cooling is different from cooling down the whole space, the whole warehouse space, like a typical traditional air conditioner. You'll save on equipment costs and insulation costs using spot coolers, as well as ongoing operating expense. Since you're only cooling down smaller areas within the larger warehouse, you're not wasting as much as you're not wasting or consuming as much energy using that type of cooling. These portable air conditioners will focus cold air on specific workstations and leaving the not-so-critical areas in the warehouse a little bit warmer. And this also supplements, even if you do have some type of air conditioning or some type of other cooling, is supplement that type of cooling and reduce your overall energy cost inside for the whole building itself. Portable air conditioners, they have two components of cooling. It's sensible cooling and latent cooling. Sensible cooling lowers the temperature, so maybe you have it starting off at 85 degrees and you can lower it down to 70 or 75 degrees. That's sensible cooling. And it also has latent cooling, which actually removes moisture from the air, and this is kind of geared towards comfort cooling for people. The moisture that you can remove from the air will help make those people feel more comfortable. So you may have a relative humidity in the air of 50%. And if you can raise it, if you can lower it down to 40%, that'll help people regulate their body temperatures a little bit better and keep cooler. So how does the portable air conditioner work, and how is it designed? Well, if you're familiar with your house AC, you'll know that the air conditioner is broken into two different sections. An indoor section that delivers the cold air inside the room, inside the house, and an outdoor section which transfers that heat to the outdoor section and exhausts that warm air out into the environment. Well, in a portable air conditioner, all those components are packaged into one cabinet. You have the evaporator coil and the fan system delivery of that cold supply air. So in the illustration below, you'll see the warm air coming in to the unit and the cold air being delivered out the nozzles. The outdoor section, the condenser coil, compressor, and fan system for the exhaust air, that's located in the back of the portable air conditioner. You see the condenser air in on the side, and then it absorbs that heat and then exhausts that warm air out through the top. Portable air conditioners are a lot more durable than permanent AC units. They have lots of air filters on their system, so they're preventing, they're filtering out dust and debris from the air and protecting the components inside the air conditioner. Also, they're designed for harsh conditions, so they're very reliable in these type of environments. So when you go into portable air conditioners, you have different categories. The biggest two is air-cooled or water-cooled. And this tells you how the air conditioner is removing that heat. In an air-cooled unit, it removes the heat via air, as you would think. And then in a water-cooled unit, it removes the heat via water. Those are two different mediums. So water-cooled is actually a very efficient medium to remove heat. So the only downside to that is you need a continuous supply of water to keep removing that heat from the air. So with that limiting factor, we find that more people use the air-cooled portable air conditioners because they're just a lot easier to use. Within those type of air conditioners, different applications exist, whether it's an office environment, so for your production plant, for your plant environment, it might be the QC department, a lab, or production office. So a smaller contained space within the larger warehouse space. And these type of units operate from 65 to 95 degrees Fahrenheit. And they have an office styling to them with a diffused louver. So that top picture shows you more of an office type environment unit. The next one down is the industrial environment portable air conditioner, and this is for production floors. They have an operating range, a higher operating range from 70 to 113 degrees Fahrenheit, and they also have these cold nozzles that you can direct the cold air to. So whether it's a process or a person or so forth, you have a concentrated cooling right on that area. And the last unit I'd like to talk about is the mobile spot coolers. These are the larger industrial units found inside the production floor as well. These operating ranges a little bit higher, from 75 to 115 degrees Fahrenheit, and These units allow you to duct along production lines and have multiple drop-offs of cold supply air to your workstation. These units are very easy to install, almost plug and play. They require about 10 to 15 minutes of installation time. The first thing you want to do is determine what type of air conditioning do you want. Is it going into a production office? Do you want the more office-styled unit with a diffused louver, or is it directly on the industrial floor, on the production floor, and have a more industrial unit? The units range from about 10,000 BTUs to 60,000 BTUs. So roughly 1 to 5 tons. 1 ton of air conditioning is equal to 12,000 BTUs. And with that, each unit requires a different voltage to operate. So the smaller units, up to a ton and a half, about 18,000 BTUs, they operate on 115 volts, and that's the common everyday voltage that you find in your house. The larger units, from 2 tons to 5 ton units, those operate on 208, 230 volts. And the larger 5-ton units operate on 460-volt three-phase power. So that may determine what units you want. If you only have 115 volts available, you may want several smaller units. Or if you have 208, 230 volts available, you may want one larger unit and have that ducted off into multiple locations. It just kind of depends on what your situation dictates. And then for the warm air that I talked about coming out the top of the unit, if it's going into a production office, you'll need to get that warm air out of the office. And a lot of times the warm air is ducted up into the drop ceiling or out through the roof of that structure. If it's going on a production floor or outdoors, you may not need to duct it at all. You can just wheel the portable air conditioner to where you want the cooling and have that warm air be directed up into the roof of the warehouse and have the exhaust fans of that structure take it out. So there wouldn't be any ducting for that warm exhaust air. And then next would be the condensation removal. Like I mentioned before, the latent cooling of the portable air conditioners, they actually remove moisture from the air. And that moisture collects into a tank, typically a 5-gallon tank, and that condensate needs to be emptied periodically because that tank fills up and shuts off the air conditioner. If you need 24/7 operation without any type of emptying that tank, there are pumps, condensate pumps, to put into the units, and you can pump that to a nearby drain or sink or water line somewhere. Those are air-cooled portable air conditioners. The water-cooled are very similar. Again, cooling capacity, the power required. The only difference is the heat transfer. So instead of transferring the heat to air, we're transferring the heat to an external water source. So you can connect this unit to cooling towers or chiller system. This water supply needs to be plentiful and economical. If it's if you're in a drought-stricken area, water-cooled might not be the best choice for you. And a lot of times these units are used, the water-cooled units are used when there's no good way to exhaust the heat out of the room, whether it's a warehouse or a lot of times medical operating rooms use these type of water-cooled units, or even basements, because you can't get the warm air out of the basement. Again, it has latent cooling, and you'll have to empty that tank or install a pump to get rid of that condensate. With these units, they have lots and lots of different accessories, and these accessories provide flexibility for the units. In terms of ducting is the biggest flexibility. So the cold supply air can be ducted from these small units up to 60 feet. The warm air can be ducted up to 100 feet. So this determines where you want to put your portable air conditioner on the production floor or the warehouse space. You can have it right next to the space that needs to be cooled, and you can duct the warm air out of 100 feet out of the way, or you can have the unit placed maybe 50 feet away and duct the cold air to the space. It just kind of depends on what works best for you. The larger units that can cool the whole production floor, these units can go up to 160 feet and have multiple drop-offs along the way. And these larger units can be hung off the floor which saves valuable production floor space. As you can see in this picture, you have a large 5-ton air conditioner that's cooling down a whole production floor or a whole production line. It's, the length of that large cold air supply maybe goes about 100, 120 feet, and then multiple different drop-offs to cool down different workstations. These drop-offs are flexible tubes that can move with the people as well. So maybe in the morning you have people working in one station and they move 10 feet, 20 feet away, and you can adjust those drop-offs to that new workstation. So it's very flexible, that moves with you. If the production floor or the production line needs to be changed for a different product, you can adjust the ducting as well to adjust to a new production line. So it gives you a lot of flexibility. You just need to correctly size the ducts, make them big enough so they can accommodate those long duct runs, and it's a great solution for a difficult cooling challenge. So with that, we'll talk about people cooling. Most manufacturing plants have these hot spots, and these hot spots can incur heat-related injuries or illnesses to your employees. They'll also drop the productivity rate of these people as well. So as the heat increases, their work will slow down. They'll need more breaks to keep cool, more water to consume. This all reduces the productivity of these employees. So if you can keep them cool, you maintain that productivity rate. As well as the temperatures get warmer, their ability to concentrate is less and less. So there comes a point where errors and accidents may increase because of the increased temperatures. And this will play into the hands of OSHA violations that may occur, whether it's heat-related injuries or illnesses or accidents as a result of the warmer temperatures inside the building. So portable air conditioners can greatly help with these type of OSHA standards that are required to improve occupant comfort. As you would think, it will reduce the risk of these heat-related injuries or illnesses. And it also improves employee morale. It'll improve the quality and the productivity of these employees and the products that you're delivering to your customers, as well as lowers the employee turnover. So if somebody's happy, they're less likely to look for a better job. Also, it could help with summer absenteeism at your plant as well. If it's a really hot day and your employees know they'll be relatively comfortable, they're less likely to call in sick. So in 1970, the U.S. government passed the Occupational Safety and Health Act, or OSHA, which states that employers are required to provide their employees a place of employment that is free from recognizable hazards that are causing or likely to cause death or serious harm to employees. And some of these heat-related hazards that could cause injury or illness are heat stroke, heat exhaustion, heat cramps, and heat rash. And on the right, you'll see a chart, and the comfort zone is from about 68 to 80 degrees Fahrenheit, and this is where you have maximum efficiency of your employees. And as the temperature increases, you'll start to notice some mental issues coming up with the discomfort of the higher temperatures. So this could be just a simple increased irritability, loss of concentration, loss of efficiency of mental tasks. So your skilled workers will become less reliable and have more accidents or errors. And then as the temperatures increase, you'll get both the psychological and physiological effects of the heat. So again, loss of efficiency and skilled tasks and more incidents. And then as you move higher into the 90s, you'll start seeing more serious physiological problems. So this is a disturbed water and electrolyte balance with the workers. They're just working harder to maintain that same productivity. So their heart has a heavier load as well as their lungs, and and the fatigue and threat of exhaustion kicks in. And then once you get into the mid-90s, into the hundreds, you really need to limit their ability to stay out in that temperatures for very long. You really need to limit their exposure to that heat and take more water breaks. OSHA always says water, rest, and shade, meaning more water intake, so having more breaks, and then limit their exposure to that heat, so more and longer breaks. So that's, that's great to know, but also what are the costs that are associated with these type of injuries or illnesses? So having one incident of heat-related injury or illness could be a disaster for a small company. There are costs both to the employers and to the employees. So the direct cost to the employees could be the pain and suffering of the injury and illness, the loss of the income for not working that day, possible loss of employment if they can't perform the job any longer, and healthcare costs that are associated with just that injury. And the indirect cost to the employees would be the suffering of for the employee's family. And then the direct cost to employer, it would be payment for that work not performed that day, any type of medical and compensation payment, reduction or temporary halt in production for that day because they have to take care of the incident, increased training expenses and administration costs, so to train your employees to better be able to handle the heat, talking to them about taking more breaks and so forth. And then the reduction in the quality of the work as the heat goes along, that definitely affects your bottom line. And then the negative effect and morale on other workers. Some indirect costs that may not be as readily visible to you are replacement of those injured and ill workers. So that takes money to try to find replacement employees, the training that goes along with those new employees, and then the reduced productivity during that training, the learning curve on the job. And then also all the paperwork, the investigation, and the documentation that comes along with the injury itself. Negative influence on labor relations. So, if you have a labor force working there, a union labor force working at your facility, that could be have negative impact on that, and also public relations that could be very impactful as well. So the OSHA website has a link to a calculator that helps you determine what the cost would be for heat-related injury. The OSHA Safety Pays program takes into account different factors and determines what additional sales you need to do to cover those costs of one incident. So heat exhaustion would be an example that I used recently this month to determine what the cost would be. And as you can see, the direct cost is $23,000, and that's covered either by workman's comp insurance or the employee or some type of combination of the two. The indirect cost would be burden the employer directly, and that's almost $26,000, with a total cost of about $49,000, which is, as for just one heat exhaustion incident, that's a huge impact, especially for a small business. And just a side note is Congress just passed a law last year increasing these OSHA fines for each violation. So the last time it was increased was back in 1990. So about 26 years ago, these OSHA fines haven't been increased at all. And starting August 1st of 2016, the fines are going to go up. So the maximum penalty for one violation was $7,000. It is now going up to $12,471 for each violation, and that doesn't count per day or anything like that. The maximum penalty per violation, counting into days that it's not being fixed, goes up to $124,709, up from $70,000 previously. And with this new law, the penalties are adjusted annually for inflation, so it's not going to be another 26 years before the penalties rise. Each year it's going to rise due to inflation. So that's just another thing to think about as well. And with that, we'll start talking about spot cooling processes themselves. So if you have a production process that introduces heat to your product, you can greatly reduce the cycle times using portable air conditioning, spot cooling. It'll also reduce the handling times of the product and reduce the rejection rates as well. So all three of those will increase the output of your productivity and also increase your profit. Like I mentioned before, spot coolers reduce moisture from the air, so this could prevent defects as well from warping or condensation, this latent cooling. And then as well as for heat-sensitive inventory storage, whether it's raw materials or finished goods, you can also keep those areas cool and keep your product well maintained. Some of the industries that have this heat-related processes could be food, plastics, whether it's injection, thermoforming, or blow molding, some type of soldering or brazing or welding. Studies have shown that we can reduce the cycle time up to 94%, the processing time. So if you take an example of plastic molding, you have a part coming out of the mold that's extremely hot but needs to have a secondary operation done to it. Maybe some flashing needs to be cut or a hole drilled somewhere, and your operator sets it to the side to cool down and waits till it cools down and then picks up the part and does a secondary operation. Well, if you can take that part out of the mold hot, set it aside to have it cooled down by a spot cooler, that will greatly reduce the time that he needs to pick up that part again to do the secondary operation. Other areas to think about is high precision machining. So a lot of times in the aerospace or defense industry, they're working with very, very tight tolerances on materials that can expand and contract with temperature swings. So whether it be a plastic part or a metal part, they could have effects on how it's cut and may not be able to keep those tight tolerances that the customer requires. So being able to use this portable air conditioner for those type of applications is a great way to keep tolerances. So spot cooling can also be done with cooling the equipment itself. More and more times now, specialized equipment is going out onto your production floor. Equipment that deals with computers and heat-sensitive types of components. So to prevent failures or slowdowns, you can keep this equipment cool, reducing the number of times that the equipment needs to be serviced. So these heat-sensitive pieces of equipment, as the temperature elevates, the frequency of servicing or component failure increases and will shut down your line. So by keeping this equipment cool, as long as you have it operating, you can operate it more and longer, and this will increase the equipment's return on investment, which is great. Some type of production equipment that may be heat sensitive would be CNC machines, control panels, automation, PLCs, anything that has IT equipment, servers, computers, and so forth. Some high-tech QC equipment that's used to measure certain types of components, labs, and so forth. So you may have units on your production floor to help you cool down hot spots, but there's also AC rental companies out there that provide emergency and temporary commercial air conditioning units. They have portable air conditioners, trailers, tractor trailers with large ACs or chillers, and then also power generators to operate these type of air conditioners all in their fleets. And they rent them out from daily, weekly, or monthly, however long you need them, and they come and install the units for you. They have a wide range of accessories to adapt to your building as well. And sometimes they can deliver same day if necessary, and then they're located throughout the U.S. and typically large metro areas. And this brings me back to our topic of emergency preparedness plan. It's always a good idea to prepare for an emergency one day. You want to plan ahead for the worst case scenario so you're prepared for it, you're not scrambling around when the emergency happens. So if something happens to your normal cooling, you want to think about portable air conditioners and generators to power those type of portable air conditioners. Again, as I mentioned before, 1 to 1.5 tons of air conditioners, or 1 to 1.5 tons of air conditioning on these portable air conditioners operate 115 volts. The 2 to 5 ton ACs operate for 208 to 230 volts. And the larger 5 ton units, either the 208 3-phase or 460 3-phase. So when you're specifying generators, you'll want to know what the load is, what the load will be on these generators, and how many air conditioners will be on there. And these air conditioners have a high inrush current that are associated with these air conditioners. So you want to oversize the generators to be able to handle these this quick inrush of current. It only lasts a couple milliseconds, but you'll need to oversize the generators to accommodate that. And then just walking through your plant, making sure you have the critical areas will be cooled in case of an emergency. And just to think outside the box as well. Think of special vulnerabilities that could happen that would affect your cooling, your normal cooling. So this isn't always a natural disaster that wipes out a whole region. This could be as simple as a normal thunderstorm that comes through and has, large hail coming down that's damaging your rooftop air conditioner. So if it wipes out your air conditioner, or high winds knocking over a tree that damages your air conditioner as well, you'll need to have some type of backup cooling to keep your operations going. And this leads to having a written emergency cooling plan. So go through, inventory your portable air conditioner that you have on hand and your accessories, and then figure out, based on the areas that need to be cooled, the critical areas that need to keep on being cooled for normal operations, and then find out what new units you'll need to have, and then contact your AC rental company, your local AC rental company, get a contact information over there and discuss your requirements. And what I would say is, if you know some type of anticipated event is coming, whether it's a hurricane or a flood, heat wave, you'll know in a few days advance time, and you'll want to have portable air conditioners on hand before the disaster strikes, because a lot of times at those instances, local demand far outstrips the supply of those type of units. So to ensure your facility has the right type of cooling equipment, you want to contact them beforehand. And with that, we'll talk about the general cooling solutions that you have available to cool down large warehouses. We'll start with fan solutions first. Fans are a great solution for cooling down a large area. They're low-cost products. The operation to run them is low. The ceiling fans can cool down a huge area. Those ceiling fans can go up to 24 feet in diameter. The cons, though, are it just kind of recirculates the hot air. So if you have high heat and humidity in that warehouse, you're not going to be able to lower the temperature at all. What you're doing is you're helping your employees have a constant airflow over them, which helps them regulate their temperature, their core temperatures. So it allows them to sweat a little bit easier to experience the cooling. However, again, it doesn't filter the air, so you might have dust or dirt in the air, which could cause some eye injuries as well. These fans they can move a large volume of air. They operate at 115 volts or 240 volts. And then the cost to operate is very low, about 3 cents an hour. So if we look at the total cost of ownership, the units themselves, the upfront capital cost is fairly low, except for when you get into the large 24-foot diameter ceiling fans. Those are a little bit higher, as well as the install cost on those, getting power up there as well. But the low operation cost is low, for all those units, and then the maintaining cost of those units, the maintenance on that is very low as well. So overall, the total cost of ownership is low for those fans. Again, you're not dropping the temperature anymore. You may be having your employees feel a little better with the airflow over them, but the total cost of ownership is low. Next, we'll talk about evaporative cooling solutions. If you're not familiar with evaporative cooling, you have a fan with a pad that is saturated with water. The fan brings air over that pad. That air absorbs the moisture and cools and drops the temperature down. The air leaving these evaporative coolers are saturated with water, maybe about 80% humidity level, and that moisture, the lower temperatures helps your employees cool off that way. The pros to these evaporative coolers, they're low in cost. Their cost of operation is low. The cons, these evaporative coolers are not effective in hot and humid regions. So a large portion of the eastern U.S. may not be effective in these areas because in the summer times, these regions have high temperatures and high humidity. So the ability to add more moisture to the air is very low. And also these evaporative coolers may not be best situated for products or applications that are moisture averse. So if you have some type of powder or some type of product that absorbs the moisture, adding more moisture to the air is not a good thing. So this might not be the best choice for you. It also requires some water. One thing, like I mentioned before, that air leaving this evaporative cooler is saturated with almost 80% humidity in the air. This can condense on certain surfaces and could cause a slip hazard near that evaporative cooler. And also, you have the wetted pad, but it does not filter the air. So you still have dust and dirt that may be in the air that could, be an eye injury to some of your employees. With the evaporative cooling, you have large airflow movement, the 115 and 215 volt operation, and then again, the cost of operation just for the fan to blow air across that wetted pad is about 3 cents an hour. There is some cost associated with the water, but it's not usually a big impact. So if we looked at the total cost of ownership for this cooling solution, we can look at the upfront cost of the unit itself, and then to install, which is very low. The operation cost is low as well, and then the maintaining cost is fairly low as well. You have to change out those wetted pads for new pads, but overall it's a fairly low cost associated with that, which will give you a total cost of ownership low, similar to the fan. If we revisit the portable spot cooling solutions that we talked about earlier, the pros to that is it delivers the cool, dry air. So it's removing moisture from the air, the latent cooling that I mentioned about, along with the sensible cooling that actually drops the temperature of the air. There's no water needed for these air conditioners, and it's an effective cooling solution for all regions in the U.S. So whether you're using it out west where it's really dry like a desert, or in the southeast where it's hot and humid in the summer times. The cons for these solutions is the higher unit cost, and then you can only spot cool specific areas within your larger warehouse. The cost to cool down the whole area would be too great. These come in 1 to 2 tons of AC, so about 12 to 24,000 BTUs. They operate both on 115 volts and 240 volts electrical. They allow to duct the cold air 60 feet away from the unit, and the cost of operation is 9 cents for the 1-ton unit and about 21 cents for the 2-ton unit. So a big jump in cost from the fans, but not terrible. Next, if we look at the larger ducted spot cooling solutions, these are for large assembly lines. Again, same pros as the portable air conditioners, the cool, dry air, removing moisture from the air, no water needed, it's effective in all regions, and the same cons, the higher unit cost. And then this one, there is some installation cost associated with it for setting up these assembly lines, ducted assembly lines. These are the larger 3 to 5-ton air conditioners. They range from 36 to 60,000 BTUs, and they operate in the higher voltage, 220 volts, 3-phase, or 460, 3-phase electrical. They allow the ducting to go up to 160 feet of cold air away from the unit, and the cost to operate these are about 29 cents to 40 cents an hour. So higher than the fans, but you're getting a lot more with it, and not terrible operating costs as well. So if you've decided you need some type of portable air conditioning in your warehouse, how do you select the right portable air conditioner for you? Well, there's 2 things that you want to look at, is the reliability and longevity of the unit, and then as well as maybe have an established manufacturer who will stand behind the product in case something does happen to it after you purchase it. So you want something reliable because it's cooling down critical equipment. You'll need it, for your production processes. They're required for emergencies, so when you need it most, you want it to be working, as well as you want it to last a long time. So is this portable air conditioner designed for rigorous standards? Does it come from a quality manufacturing process? The upfront cost and how much it costs to purchase the unit and install the unit is easily calculated, but what is the maintenance or the service cost of these units? So high quality unit, the service cost will be a lot lower than a lower quality unit. And these are the hidden costs that you need to think about. So a lot of times these features come from an established manufacturer, is the manufacturer and industry leader in their department in this segment. Do they offer, what type of warranty do you offer? Is it both parts and labor on the unit for multiple years, or is it just parts only? And then from an established manufacturer, you can usually trust their published specifications. Are you getting as much cooling capacity that you're paying for? Sometimes manufacturers will kind of fudge a little bit or just overemphasize the cooling a little bit where they shouldn't, or the energy efficiency of the unit. How much is it really costing you to operate this portable air conditioner? And with that, we'll talk about the total cost of ownership. If you have a quality design portable air conditioner, this will lower the overall total cost of ownership. And this is what you really want to concentrate on, because if the unit's maybe 10, 20% higher initially, what is its cost, down the road, the whole life of the product? So air conditioners are mechanical equipment, and unfortunately, all mechanical equipment will fail sometimes. So trying to figure out what the mean time between failure is important in your purchasing decision. So you'd want to look at internal components. How is it designed? Like a motor, that's a critical component within that air conditioner. Do they use fully enclosed motors? So an open motor will allow moisture and dust and lint to get into the windings, which could cause shorts or corrosion with the motor and could cause a failure. The casters, it's a portable unit, so you want it to get around, withstand bumps and going up curbs and down curbs and so forth. What type of material is being used for that caster? How is it mounting onto that unit? Is it just a stem caster, which is easily broken, or is it bolted on with weld nuts and bolts? And it all depends. The sheet metal inside that design the units, is it reduced? Do they use a proper design for reducing stress? And the fasteners, is the machine screws used so you can service the unit easily, or low-bearing sheet metal stress or sheet metal screws? The refrigeration system, is it hermetically sealed? A lot of times units will have service valves on there that leak out refrigerant. You shouldn't have to recharge your unit. And then also the pipes have a high internal stress and from vibration and high pressures. If they're not designed properly, they'll lead to cracks, which may lead to leakage of refrigerant. So doing your research on ACs will be very helpful. It's an expensive capital purchase. Ask your manufacturer questions. You're not going to get this information by just looking at pictures on the internet. So you want to lower your total cost of ownership. Again, the acquisition cost is very simple, easy to calculate, your purchase price plus your installation cost. But the life cycle costs are a little bit harder to calculate. What is the maintenance cost, the service life of this unit? If a unit lasts 10 years compared to 5 years, you're going to greatly reduce your total cost of ownership. And with that, let's wrap it up and talk about the benefits of spot cooling, increasing your revenues by increasing your worker productivity, your cycle times, your throughput. It lowers defects and scrap rates. It also reduces downtime by keeping equipment up throughout the production time. It also lowers expenses. So instead of buying a large traditional AC with high capital costs, or extending the capital equipment of your production equipment by keeping that cool. It uses a lot less energy from traditional ACs. It reduces heat-related injuries and illnesses, or the training needed to replace those employees with those injuries or illnesses, and it eliminates OSHA fines. And with that, I will turn it over to Bob now, who can facilitate the question and answer session.
Great. Thanks so much, Jim. Great presentation. We got a lot of questions from the audience, and we'll get to as many of those as we can. You still have time to type questions in for Jim in the Ask a Question box on your screen. We'll get to as many of those as we can in the next 10 minutes or so. Within a few days, this presentation will be available for on-demand viewing, and we'll post the archive on the Plant Engineering website. We'll send you an email link with a connecting directly to it and to the related resources from today's presentation. As I said, we've got a lot of questions that have come in. Let's start with this one. And it kind of goes to a number of the things that you talked about in the presentation. Dan Sebald says, could you speak about electrical supply for some of the higher voltage portable units, grounding requirements, workplace safety, that type of thing?
Okay, the larger units do require the higher voltage. So the 2-ton on up requires the 208, 230-volt power, as well as the larger units may require 3-phase power. So they all require grounding. They all come, the smaller units come cord connected. The larger 5-ton units can be hardwired to your facility, and they all definitely need to be powered, grounded, and just follow local codes for the electrical codes in your region. Yeah, I think hopefully I answered that one.
Very good. A couple of questions from Danny Berry at the Ford Motor Land Development Corporation. First of all, is industrial ducted referring to the cold side or the hot side?
So the industrial ducting can be referred to either side. Like I mentioned, the smaller portable units, you can duct the cold air up to 60 feet from the portable air conditioner. So you don't have to have the air conditioner if it's not if floor space is not readily available to that heat to that workstation. You can have it up to 60 feet away and duct the cold air into there. However, if you need the unit right next to the workstation, you can also duct that warm exhaust air 120 feet away from that portable air conditioner. So when I refer to ducting capabilities, I refer both to the cold side and the exhaust warm side, which gives you the flexibility on the location on where to best situate your portable air conditioner.
Very good. And another question from Danny, what are the restrictions for ducting the condenser heat out of the space? Does the 100-foot mentioned apply to all types of units? And is the 100-foot an equivalency, and is there a degrading of the unit with ducted condensed air? So there's a lot of questions there, more than just one.
Yeah. So the 100 feet is based on certain units. So the larger units can duct it farther, typically. Actually, I take that back. The smaller 1-ton units conduct the warm air, 60 feet or so. The larger units conduct the warm air up to 45 feet. And then as you get larger with the mobile air, the larger hanging units, you can also duct those a little bit farther as well. So it just depends on the unit you're looking at, what size the unit. It depends on the fan and the motor inside the unit to see how much static pressure that it can overcome. So it's hard to give you a general answer, but it's more dependent on the specific air condition that you're looking at.
Very good. And kind of a follow-up, there's a kind of parallel discussion on that from Dan Sebald. Are there any strategies for portable cooling units that utilize the fact that warm air rises, such as keeping upward exhaust flow free from obstructions?
Definitely. So you may not even need to duct the warm air on a production floor. It all depends. So if you're cooling down a workstation, I know some people put in, some 8 feet of self-supported duct, and that'll direct the air up above people, the workspace down below, and just keep that air, since the hot air rises up there. But I also know some customers that don't even put any type of ducting. So the hot air is directed, up from the unit, and that warm air will just generally rise. If you go around the unit, it might be a little bit warmer by the unit, because that warm air sticks around just a little bit before it rises. So that may not be something that you want, but it's installed both ways on the production floor, whether it's a little bit of ducting to get it above the workspace or nothing at all and just have it generally rise up to the roof.
Very good. Good question here from Carl DePolt from Green Building Solutions and Supplies. Are evaporative coolers similar to dehumidifiers?
Actually, evaporative coolers are the exact opposite of dehumidifiers. So dehumidifiers take out moisture from the air. So you may have a dehumidifier in the southeast where it's really hot and humid, and you want to lower that humidity rate in that space. So you're actually removing moisture. Evaporative coolers are adding moisture to the air. So in hot, humid areas, you don't want to add more moisture, or you're just adding to the problem for comfort cooling. So evaporative coolers are used a lot of times more in the western part of the U.S. where it's dry, arid weather. So adding more moisture actually will reduce the temperature of the air and not really have an effect on the employees inside the building.
We have a lot of readers in the and attendees in the food manufacturing area. Talk a little bit about food safety and portable air conditioning systems.
Sure. Portable air conditioners are great to maintain a temperature for the food so it doesn't spoil, whether it's raw materials or finished goods. A lot of times they come out, from a heat process. It's being baked out of an oven, and they'll need to cool it down to actually reduce the cycle time before it's packaged up in its packaging, since you can't really do that while it's still hot. So the portable air conditioners work well with the processing to lower in the processing time, but also maintaining a lower temperature. So whatever food that you're working with, it just depends on the type of food that you're using. If it's going to melt or if it's going to spoil with higher elevated temperatures, portable air conditioners will give you anywhere from about 15 to 25 degree temperature drop. So if the temperature inside the warehouse is 75 degrees, and you have low humidity equals a bigger temperature drop. So 75 degree air in will deliver maybe about 50 degree air out. So keeping that 50 degree air onto that food, whatever it is, will help with reducing your spoilage with that food safety.
Very good. And that's the FDA is always watching in those facilities, so it's always a matter of balancing those two ideas of making sure that the process is as cool and comfortable as possible for the employees and for the process, but at the same time maintaining the integrity of whatever the finished products are.
Definitely, and then also if you want to think about it too, these portable air conditioners have filters on all their intake valves, so you're also filtering the air, you're not blowing around dirt and dust onto the food product as well.
Very good. Another question from the audience. Are there system integrity self-checks, for example, checking for loss of compressor gas pressure?
These systems, the portable air conditioners don't have that, but the best way you'll find out if something's wrong with the gas pressure inside there is it's not cooling properly. So if you're not getting a big enough temperature drop, say you're only getting a 10-degree temperature drop from your unit, maybe you're low on refrigerant and your pressures aren't correct. Also, if your evaporator coil is freezing up, again, you might have some type of blockage inside the unit, or you might be low on refrigerant. So there's not really a gauge or indicator to tell you, hey, the unit's low on refrigerant, but you'll know in the symptoms that are coming out of the portable air conditioner.
So this kind of goes to one other question that we've gotten. This might be the last one we've got some time for today. But are there any kind of sensors, thermostatic sensors, somewhere tied into the portable units themselves, or are they primarily manual control?
No, most of the portable air conditioners are electronic controllers. So they'll have a minimum of two different sensors. One is the sensor measuring the return air back to the unit, so the air crossing the evaporator coil, it'll measure that temperature. So if you want a set point of 70 degrees and the air returning to the to the air conditioner is below 70, it'll shut itself off and cycle itself off until the temperature rises above. The second sensor, temperature sensor inside the unit is called what they call a freeze thermostat, and that is attached to the suction tube, which goes to the compressor. So to prevent any type of evaporator coil freeze up or slugging the compressor with liquid going back to the compressor, that sensor will prevent that from happening and protect the compressor, which is very expensive to replace. So there are some internal sensors on there as well.
Very good. Well, that's a great presentation, and I want to thank Jim Magnanianis, President of Technicool Innovations, for the great presentation today, and just a lot of great information, a lot of great questions.